The next thing we're going to go over is pedigrees. So a pedigree is a family tree that shows males and females that are either affected or not affected by a specific trait. So things that you need to know is two lines that join a square and a circle means a marriage. A square is a man and a circle is a female. And when we talk about male and female in these, again, we're referring strictly to their sex chromosomes. So this individual has an XY and this individual has an XX. These two individuals produced the following offspring. This female first, then this male, then this male, then this female, then this female, then this male. So the line that drops down from their marriage line per se indicates all of their offspring. And then you'll notice that some of their offspring, some of their kids, got married or had a partner or whatever and had another generation. So this is technically like grandparents, parents, aunts and uncles, and then you and your cousins would be down here. A male who is affected with a disease is going to be shaded, and a female that's affected will also be shaded. So this shading of the boxes and the circles indicates Huntington's disease. The first question is which members of the family above are affected by Huntington's disease? So all I would do is I would look for those individuals that are shaded. So individual 1, 2, 3, 7. And then individual 3 in the third generation. So what I would write is, if this was a problem like on a test, I would write generation I or 1 is individual 1. And then in generation 2, I have 2, 3, and 7. And then generation 3, I have individual 3. So that's how I would write that answer. I need to make sure that I indicate which generation I'm speaking about because the numbers repeat themselves. Question number 2. There are no carriers for Huntington's disease. Either you have it or you don't. With this in mind, is Huntington's disease dominant or recessive? So let's think about it. You either have it or you don't. In order for it to be a recessive trait, that means it's a lowercase letter, and in order to have it, you need to have 2 of the recessives. That also means that if it is a recessive, then I could have an individual who has a big A and a little a and not be affected. So that means if it's a recessive, there are carriers. This tells me that there are no carriers for Huntington's disease. So because there are no carriers, period, you either have it or you don't, means that it's a dominant disease or a dominant allele that is affecting whatever genotype we're talking about. Next question, how many children did individuals 1 or I1 and I2 have? So that's this first generation. They had 1, 2, 3, 4, 5, 6 kids. How many girls did generation 2-1 and 2-2 have? So 2-1 and 2-2, how many girls? They had 2 females. How are individuals 3-2, so 3-2 and 2-4 related? So how is this individual and this individual related? Well, this female come from these 2 parents, and this parent, this mom, had a male sibling. So I-4, 2-4 is the uncle of 3-2. All right, let's look at this one real quick. The pedigree above shows the passing of color blindness. What sex is most likely to be carriers of color blindness? So a carrier is indicated by a half shaded symbol. So if I look here, this person is affected, this one's not affected, this is a carrier. So the only carriers that I see are all circles, and circles are females. So the sex most likely to be a carrier is a female. Why does individual 4-7, a female, have color blindness? So I need to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So why does this female have color blindness? Well, I need to look at her parents. Her dad is colorblind and her mom is a carrier. So that means she inherited 2 recessive alleles. And what I mean by that is mom's genotype is going to be X, big A, X, little a, and dad's genotype is going to be X, little a, Y. So because mom and dad both have these recessive alleles here, we're going to say that she inherited both of those recessive alleles from mom and dad. So individual 4-7 has color blindness because mom is a carrier and dad is affected, meaning he is colorblind. Why do daughters in generation 2 carry the colorblind gene? Well, they carry the colorblind gene here because dad is colorblind. And number 9 lists 2 4th-generation colorblind males. So 1, 2, 3, 4, individual 1, and individual 2, 3, 4, individual 5. Individuals 1 and 5 are colorblind.